the genetic variants that would have allowed him as an adult to digest milk. So he would have been lactose intolerant. This in itself is not particularly surprising because obviously this was a time before farming and before domesticated animals. So he would likely not have been exposed to any dairy products anyway. In relation to Cheddar Man's phenotype, or what he physically looked like, we describe Cheddar Man as having dark brown to black hair colour, blue or blue-green eyes, and dark or dark to black skin pigmentation. So I'm just going to focus straight in on the skin pigmentation result because this is what's caused the most issues for people. So human skin pigmentation is a very, very complex trait. It's what we call polygenetic, meaning that there are many genes and many gene variants that affect it. We probably don't know all of them, and we certainly don't know how they all interact. Indeed, it's fair to say that in recent studies from modern African populations, they found more than 100 places in the human genome where people vary, where there are variations that can be associated with skin pigmentation. So to sort of clarify, these are sites in the genome where I might have a C and you might have a T. And when individuals have a different base at a single site, we call it a single nucleotide polymorphism, or SNP for short. So you quite often hear people talking about SNPs, and that's what they're talking about. So there are a lot of these SNPs associated with skin pigmentation. Some of these variations are found specifically within genes where we know the effect of those genes. And the effect of those genes are, they can be on genes that make either a different type or a different amount of melanin. Now, melanin is the body's natural skin pigment, and so this will affect the amount of skin pigment that an individual produces.
We all have it.
Yes, we all have those genes. And these genes have names, and the important ones are ones like MC1R, and in Europe, specifically in Europe, there's a suite called the SLC genes, 24A5 and 45A2 are the key ones, and another one called TYR. But what's interesting is, so whilst there are many, many SNPs associated with skin pigmentation, the most recent studies are indicating that only a few of these SNPs, only a few of these variations seem to be responsible for the largest effects in skin pigmentations, the largest differences, and that these SNPs are shown as signals of selection in populations through time. So with this kind of background in mind, we can go back to Cheddar Man and explain exactly what we did there. So what we did is to apply a specific tool called the H-Iris Plex S system. Catchy name. But it's actually used to predict the eye, hair, and skin pigmentation. It's a tool that's designed to be used for forensic cases and to predict pigmentation based on variations, so based on SNPs in an individual's genome. So the eye colour test is based on 6 SNPs, the hair colour is based on 22, and skin pigmentation is based on 36 different SNPs. So this is not the 100 SNPs that you might find in a modern African population, but 36 SNPs that are known to have a large effect in Europe. So these are these ones like these SLC 24A and 45A2 that I was talking about. And what this tool actually does is make a prediction based on a statistical model that has been trained on empirical, so real data. And what it does is it gives a probability score that reflects the uncertainty, because of course this is actually very difficult to predict. So it reflects uncertainty by giving a probability score, and these scores are then used to look at very broad categories of pigmentations, specifically a thing called the Fitzpatrick scale, which is used in dermatological skin assessments, and it categorises skin pigmentation into 6 broad categories that range from very pale white right through to very dark brown black. And it was this tool that we used to generate probability scores to predict the results. So when you say, can I be sure? Can I be 100% sure? No, because it's a very complicated trait, and it's always possible that a genetic variant existed in the past, so there was perhaps a SNP in the past that we don't see any longer today that would have conferred a different skin pigmentation. However, as there seems to be a very strong selection for lighter skin pigmentation in more northerly latitudes, I think we're going to talk a bit more about this in a moment, I think, then one would imagine that if this variant had existed in the past, then this too would have had a very strong selection for it to continue in Europe, in northerly latitudes, and so we would still see it in modern populations. So in the absence of these unknown genes, but based on the genetic data that we obtained, the genetic variants within genes that we sequenced, the probability scores from these modern-day forensic tests that we applied, personally, yes, I remain confident in our assessment that Cheddar Man had dark or dark to black skin pigmentation. And I would also finally add that this wasn't actually unusual. So there are other Mesolithic hunter-gatherer individuals whose genomes have also been sequenced from across Europe, and they too have been identified as having this darker skin pigmentation coupled with this very light eye combination. So to my mind, no, we really shouldn't even be that surprised by this result.
I'm going to play